This conference will now be recorded.
Hey, hello everyone. Want to welcome you to the Satellite Book Club seminar series. The title of our talk today is Progress and Improvements for Satellite-Based Cloud Layers and 3D Cloud Data. Our presenter is YJ No, research scientist from CIRA, and our facilitator is Sean Campbell. Sean's a senior aviation meteorologist from the Domestic Operations Branch of the Aviation Weather Center. We'll welcome both of them in just a moment, but before we get started, just a few of our routine administrative reminders. As you heard, today's session, as usual, being recorded. We'll take Q&A the usual way. Participants are encouraged, as always, to put your questions, comments, and feedback in the chat, and the team here is prepared to queue those up for our meeting notes so that the facilitator and the presenter can address them. Most of you are already doing this, but we always encourage you to sign in with your full complete name so we know who's here. And if we need to follow up with you, we'll know where and how to reach you. We are always looking for presenters for future talks. We've got a couple lined up for July, and we always try to keep scheduled out a few weeks ahead. So contact the TerraRest team if you're interested in participating in a satellite brief and either as a presenter or a facilitator, either or maybe both. And then, as usual, also, the training team can help with preparations of training materials or product materials that might not yet exist, or they can help you develop more, and as well point you to existing materials that are out there that could bolster your talk. And Brian Mata is the focal point for that. Please reach out to Brian directly. Some thank yous are in order. First of all, thanks to Kashad for getting us all lined up here today, as usual. The Chief Learning Office of the Chief Learning Officer, GOES-R program, JPSS program, and our speaker and facilitator. In just a second, I'm going to turn it over to YJ. But before we do, I'd like to give just a little bit of a background of some of her bio and her experience. After completing her PhD in meteorology at Florida State University, YJ joined CIRA in 2006 and has been working on satellite-based cloud and precipitation measurements as a research scientist. Her research interests are cloud height and layer retrievals using active and passive satellite data and mixed phase cloud studies. YJ, welcome back to the Satellite Book Club.
Okay, thank you. I'm Yoo-jung No. People call me YJ, working at CIRA CSU. So since my last talk in January 2021, time flies. So today's talk is about some updates and further improvements for our satellite-based cloud layers and the 3D cloud data processing efforts here. So first, I'd like to thank to all of my CIRA colleagues here, and especially our collaborators and the Alaska users for endlessly supporting this research. Next, please. Okay, as we all know, satellites have been providing valuable cloud observations. One click, please. But the satellite cloud data, usually from conventional sensors such as ABI and VIIRS, is often limited to 2D cloud top view. So our goal is to provide more quantitative cloud vertical information as shown in here on the left. It's the cloud layer products. Next slide, please. So I grabbed this cloud product list from JPSS website. So we have so many cloud product together with the other satellite imagery product here. But one click, these information usually from cloud top or vertically integrated cloud properties like a cloud water path. Next slide, please. So our goal is to provide more information about the bottom part of cloud. So enterprise cloud-based height product And this product is also used to improve another cloud product called Cloud Cover Layer product. So our topic is about this product today. Next, please. So it's a short background of our research to develop this cloud-based height algorithm. So you can find more technical details in our paper here. So on the left, you can see a combination of NASA A-Train satellite, Aquamoris, and CloudSat Calypso. Using those data sets, we drive the global statistical lookup table to drive cloud geometric thickness. So from cloud top, we can obtain cloud-based height using this global statistical lookup table information. So one click, please. Using this cloud-based height algorithm, we can have more lower level of cloud vertical information like this in the picture here. One click, please. So this information is used to improve this cloud cover layer product. All these algorithms are now operational for JPS spheres, and the goals are ABI series as part of the NOAA enterprise cloud algorithms. So hidden under cloud top layers, we have missing information about cloud base, but using this new approach, we can have more information about lower part of the cloud layers. So initially we started with the only high and mid and low level categories, but as you can see in the slide, we can have a more vertically extended cloud layer information. This red colored information here. So high plus mid, or mid plus low, or deep convections like high plus mid plus low layers. Especially for aviation users, we also using different, level threshold based on flight level, as like this, using different units, of course, 1,000 feet. Next, please. So all this product is available publicly in our CIRA slider tool, which is very popular now. So on the left, you can see GOES 16 ABI geocolor example with the GLM overlaid. Now we can see where is the cloud in vertical levels. Like you can see orangey colors for low cloud, and some combinations of high plus mid in blue, or deeper convections like a purple colored here. So all information is publicly available. You can see the link here. Next, please. And we started providing this improved cloud cover layer information to AWC forecasters in AWIPS 2 system using CIRA's ADM. So this is one capture. So this is layer cloud fractions from the top. This fractions between surface and 5,000 feet, and the next level is about up to 10,000 feet and the upper layers. So this product will be operational in ABI. So actually we are providing this information first to AWC forecasters for early view of this operational product, and also for product evaluation. Next slide, please. So supporting the NOAA JPSS Aviation Initiative, which has been facilitated by Jeff Wainwright, NOAA OSTI, and currently by Jeremy Goldstein. So we have been interacting closely with the aviation users, especially Alaska users. We introduced this new approach to combine all the satellite-based cloud product in one shot here. This is one example cross-section between, one click please, over Alaska, between Nome and Anchorage airports. So you can see all the terrain information in the cross-section. So vertically, we can see cloud boundary information vertically from cloud top to bottom, colored by cloud phase. And based on aviation user feedback, we added PIRAP information, especially for turbulence and icing data here together. And also we added the temperature information from new caps for ABI Beers case. And if not available, we can also use NWP-based temperature data here. So this product has been improved by very intensive user interactions, and user feedback was very valuable to improve this product. So even the colors are actually carefully selected for color weakness people here. So we started with this research over Alaska first. Next slide, please. As requested by CONUS users, we also launched the CONUS domain, as shown here. So for CONUS case, of course, we can add ABI geostationary data as well as fears here. So for popular flight path over CONUS, we can see all the cross sections. It's one example between San Francisco and Denver airports. You can see high terrain here. And of course, we can see turbulence and the icing information from PIRAP data together with all the cloud vertical level informations here. So for science purposes, this tool is also providing good information for intercomparison between VIIRS and the ABI cloud products, especially for vertical layers. Next, please. So user engagement is a very critical component of this research. So this research effort has been advertised in many social media or other official website here. One click, please. Recently, we started providing this information for NTSB aircraft accident case investigation. This is one example, one accident near Fairbanks over Alaska. Luckily, we don't have any big loss about this accident, but this shows a very good example for this satellite cloud product potential for very various usefulness for this kind of application. And next, please. This is another example. It's very fatal aircraft crash case near Estes Park, Colorado. So we provide this information for NTSB investigation also as a supplementary observational data. So you can see on that day, there are so many turbulence reports from the Denver airport as well. So next slide, please. So again, user feedback is a very critical, important factor in this study. Usually this feedback has been driving another step for our studies as shown here. So thanks to Tom George and Adam White, Alaska pilots, this research has been introduced in Alaska pilots, the Aircraft Owners and Pilots Association Weather Survey report. So top request by local pilots was to create their own cross-section, not just for a popular flight path. So this led to our current effort to develop a new aviation website with the user interactive functions for custom cross-section product. Next, please. So this is one schematic diagram to provide the satellite-based 3D cloud data for custom cloud cross-sections as requested by pilots. Our ultimate goal is to provide a comprehensive data package to extend the benefit of this satellite-based cloud data into vertical dimension, especially for aviation users. But there are so many data processing behind. So this is just one concept picture here. So usually cloud products, operational products are 2D pixel-based data and individual data products. So we combined and interpolate all this 2D cloud product together with some supplementary data such as temperatures or terrain and other pilot information together into one gridded 3D cloud data box is shown here. To reduce the data size, we are using a compact 16-bit integer approach into an SCDF format. And for Alaska domain, we are using 1,000 feet vertical resolution and 0.02 by 0.02 degree resolution. And we are also using very traditional inverse distance and the nearest neighbor method to interpolate all these different data resources. Next, please. So we recently launched a new aviation website. You can click the address here. So you can select the airport by directly clicking random waypoint over the image, or you can use the manual entry or drop-down list menu here. So you can create your own cloud cross-section as shown here. So you can also overlay pilot information, either icing or turbulence information or both. And the user quick guide documents are available in the website as well. One click, please. More importantly, one click, please. There is a user online surveys form is available. So please drop by this website and provide your information, please. This survey form has been made by local pilots and Alaska NWS operational forecasters. So you can see two different sections for forecasters and pilots. And one click, please. Or you can directly leave your message or feedback. Very simply click this image and write your reports or feedback here. Next slide, please. So also still 4-week archive is available at that website too. And recently we are trying to add a corners domain for this custom cross-section products. So it's still preliminary. One click, please. So we are working so hard now to launch this corners domain next month. So you can provide all your feedback here for this corners domain as well. Next slide, please. So as well as this kind of a product demonstration to our end users, or the science improvements are also ongoing. Multi-layer cloud is one of the top priority for our work, especially for aviation applications. Click, 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 please. So real clouds are not the very simple, smoothed ones. It's more complicated since, of course, those complexities are making our work so hard. So our target is in multi-layer cloud scenes, how we can detect a lower part, especially for aviation users. Next slide, please. So together with the very traditional statistical approaches, we are also using machine learning approaches here for especially multi-layer scenes, which is very important for new cloud layer category like a high plus low. We started with ABI data with the CloudSat radar and the Calypso LiDAR data as a ground truth. Because for ABI case, we have more chances to make a more matchup cases between this passive sensor and spaceborne active sensor, this CloudSat and Calypso. CloudSat and Calypso data provide very unique capability to look through the whole vertical cloud column, as you already know. So we are using these combinations for data training. And we are also using random forest and very traditional neural network approach for here. More technical details, you can find all the information in our recent paper here. And we are also working on this model transition from ABI to VIIRS using transfer learning approaches. And we are also tackling this issue for all level profile estimation, not just the lower part detection here. So on the right, it's one example how the machine learning based cloud cover layer product working. So top figure shows our current cloud cover layers improved by cloud-based height information. We can see all the extended vertical level information here. One click, please. With the machine learning approach, we can find more lower level cloud information, deep cloud, colored in purple. And it's small pixels here, but we have new high plus low pixels colored in pink here. So it's from all machine learning approaches. And one click, please. And this data has been evaluated using metadata. For example, near Colorado and Nebraska Panhandle area, you can see all the lower part information from machine learning approach is better represented here. Next slide, please. So again, this information is available publicly CIRA's website slider here. So it's a similar look to my previous slide, but now you can see a new category, high plus low from machine learning approach. So same demonstration and display, but we please note we are working on behind the order, this scene with the science improvements. Next slide, please. So it's another preliminary approach using AI-based model development. So not just the cloud level detection or boundary information, we are also tackling more quantitative estimation of a cloud product, including cloud water path profiles. We are building CNN and the AN approach for these problems using, again, CloudSat radar data as a ground truth. We are using matchup data between VIIRS and CloudSat. And ultimately, we are trying to get bottom right profiles for cloud water path. So this is very important to complete the whole satellite-based cloud structure information, and potentially and hopefully we are expecting this information can help improve the vertical icing potential detection based on satellite data. Next slide, please. So again, it's very important, sorry, interacting with the end users and of course operational users. Especially AWC. So we've been collaborating with the AWC researchers and the forecasters to leverage our expert and their expert to improve cloud vertical layer products. Of course, AWC is expert to provide or cloud information for aviation users for a long time. So this is one example for AWC's future development efforts for graphical forecast system. So they're developing cloud vertical cross-section information based on the NWP data. And as shown here, we are developing satellite-based cloud vertical layer information here. So we are working together to improve these cloud vertical information and all the products for aviation users. Next slide, please. So this is my final summary slide. We introduced a new approach to provide multiple satellite-based cloud data as a cloud vertical cross-section. So this is a preliminary step to provide the whole 3D cloud information for aviation users. So we are getting more feedback to step forward. And we are now constructing fully gridded satellite-based 3D cloud data. Now available for Alaska, but soon to be over CONUS. And we are also working on global 3D cloud data. And also preparing for GOES 18 and the upcoming JPSS2 VIRS data as well. So another improvements for science algorithm side, and of course validation we are also working on in many ways. Again, most important part of this research is user developer interaction, and user feedback is most important here. So please join us, and if you have any feedback or some needs, please share us so you can join this new development effort together with us. So thank you, and any questions?
Thanks for that great presentation, YJ. Just a reminder to everyone that's on the call today to please stay on for the discussion. We especially encourage participation from field and forecast offices and regional headquarters. If you have a question, again, make sure you specify your full name in the chat when asking that question. And don't forget to complete the feedback survey that's posted in the chat room. A week from today, on Thursday, July 7th at 12 p.m., Javier Viegas Bravo, the GOES-R satellite liaison to OPC and WPC, will discuss the NOAA 20 VIRS and Sentinel-1 synthetic aperture radar fusion burn scar extent and severity mask. For those of you who might have questions about the SBC, or if you might have questions about the configuration of satellite products, feel free to contact the Tower S team at any time. Tower S team is Lee Byerly and Kashad Bowman. Okay, now we are going to go on with a little bit of discussion here. The first question for you, YJ, and you may have already answered this partially in your presentation. This is from Warren Blyer. The question is, in cross sections, what are the vertical resolution and margin of error?
Yeah, it's a good question. Currently, we are using 1,000 feet. I know it's not very high resolution, but considering the data processing behind, so we choose the 10,000 feet. And the errors, it's all for cloud top and cloud base operational product. So errors are all belong to the current cloud product errors as well. And unlike NWP data, it's hard to figure out level by level errors here. So it's sorry. So it's all errors based on the operational cloud product.
Okay, thanks for the answer. Another question kind of along those same lines that follows a little bit from the answer you just gave from Mike Jamolkowski is, do you have any way to verify the accuracy of your algorithms? And I think you just kind of discussed a little bit about that.
Right, this is very important part actually. Again, this is cloud-based site, so it's not easy to get observational data to compare, but we are using surface-based radar, LiDAR, accelerometer data from ArmSite. And we are also using METAR data, but METAR data has a better spatial coverage. But problem is this cloud-based height algorithm is very subjective to the accuracy of a cloud top. METAR data doesn't provide the cloud top information, but marginally we can also use METAR data for spatial evaluation. And we are also adopting independent CloudSat and Calypso LiDAR data for this product evaluation. So we are trying to get more data resources as much as we can get for this data evaluation. And another inter-comparisons with the NWP data product, also one data source for inter-comparison.
Okay, thanks for that answer. Another question is from Mark DiMaria. He asks, what are your plans to transition your algorithms to NESDIS or AWC operations?
Yeah, it's a cloud-based height or cloud cover layer product is already operational, but I think Mark is asking about 3D cloud cross sections. So still experimental product. Again, this product has been introduced to aviation users based on user request and feedback. So we are now using some sort of a reverse path from users to operations, user needs to operation. So we are providing this product on the website based interface so far. But of course, we are working on the AWIPS 2 implementation of this new 3D satellite cloud product. But as you can imagine, this totally new data format and the new concept. So we try to utilize a pre-existing plugins in AWIPS 2 currently, like a volume browser, which has been used for NWP data, but still we have so many issues and challenges. So actually, after my talk today, we are about to ask some questions to our team for help.
Sounds good.
Yes.
Another question, this is just a general question, is do you have any plan to use NWP model data for the improvement of this product, or is there any interaction with the model community?
Right, that is very important part. That's why we started all the collaboration, the discussions with the AWC. They're expert. And of course, satellite data have so many advantages, but especially for ceiling data, very low cloud part, we have so many limitations. Of course, we are using machine learning approaches to improve this product, but we are thinking NWP data can provide useful information about that, especially AWC has been running very high resolution model information and data sets, especially for aviation applications. So we are working on that, and I'd like to say this is an ongoing effort and work in progress.
Sounds good. Another general question, I think you may have talked a little bit about this as well, is there a plan to combine multiple satellite data, and are there any potential issues?
Yeah, that's planned, of course. I showed some example from individual products from VIIRS and ABI. We are working on to combine both, as you expected, all the different geometry of different sensors have some issues. So we are working on combine smoothly this cloud data from multiple satellite sensors. So I said we are working on global 3D data. That is very important part. We are working on some interpolations using parallax corrections and some statistical approaches to combine both data sets. So yeah, we're still work in progress, but again, hopefully we can provide some more updates in hopefully upcoming or next presentation, maybe next year.
Sounds good. Those are all the questions I see at the moment. I'll give folks another minute or two to ask any other questions or to post any other questions in the chat room that they may have. Okay, here's another question from Mike Jamolkowski. Looking ahead at next-gen polar and geo satellites, is there any new sensor data you would like to see to improve your algorithms? That's a good question.
Yeah, it's even upcoming JPSS 2, hopefully NOAA 21, will be available to us very soon, and we're expecting we're gonna have a better spatial and time coverage over polar regions with this new satellite. And of course, GOES 18, and for the GeoXO, we have new channels. Hopefully, we can utilize this new information to improve our algorithm. And NASA side, we are expecting some sort of new active spaceborne sensors like AOS and UMSat's EarthCare satellites. Yeah, it's so many future capabilities are waiting for us, and we are expecting more improvement using new data sets.
That's always the goal, improvement, isn't it?
Right.
All right, I'll give another minute or so for any final questions. Or at least just a little while. I don't actually see any other questions coming in, and I actually don't have any questions myself because you answered most of the questions that I'd already written down. So with that, I will at least pass it back to Brian so he can take over and finish for us.
Thank you.
Thanks again, YJ, for the great presentation.
Okay, yeah, Brian Gockel here, and very interested in this. I didn't have any questions. I think so many topics were well covered in this. It's a relatively short brief, but very complete, hitting on a lot of the hot button items, or not necessarily hot button, but kind of aligning with some of the strategic directions we're moving in for future satellite products, the multi-satellite aspect, the multi-sensor aspect, human viewable products enhanced with potentially machine learning. We're interested in working with you as you prepare for the transition of the 3D Cloud product into AWIPS, and it sounds like you're already opening up those discussions. So look forward to helping you with that. Very exciting research and development that with a lot of operational potential. So thank you, YJ and Sean, respectively, for your talks and your expert facilitation. We appreciate you joining us today. I want to thank you on behalf of all of our participants, many offices and experts represented here today. So thank you for your brief and the questions. And then lastly, as Sean mentioned, just a reminder that a week from today, we'll have our next seminar. Javier will be briefing us on the NOAA 20 VIIRS and SAR, Sentinel-1 SAR fusion burn scar extent and severity mask. Look forward to seeing you and hearing from you a week from today. Until then, thanks everyone. Have a great day. Appreciate your participation.